Welcome to this tutorial on optimizing SQL queries for large datasets. This is what we are going to learn today in this video. Stay tuned till the end. When working with large datasets, query performance can become a critical issue. Without proper optimization, even simple queries can take a long time to execute. In this video, we will learn how to optimize SQL queries to improve performance and make our data retrieval more efficient, especially when working with large tables. A query execution plan shows how SQL processes your query step by step. It helps you identify bottlenecks by showing you whether full table scans, index scans, or sorts are being used. Tools like Explain in MySQL or Explain Plan in Oracle are essential for query optimization. For example, this query provides a breakdown of the query execution process. Indexes are one of the most powerful tools for improving query performance. An index works like a book's table of contents, allowing SQL to quickly locate rows instead of scanning the entire table. However, adding too many indexes can slow down write operations, so indexing should be used carefully. For example, this query creates an index named IDX department on the department column. Indexes are like a directory that helps databases quickly find data without searching every row. A full table scan occurs when SQL has to examine every row in a table to find the result. This is fine for small tables, but can lead to major performance issues with large datasets. Avoid full table scans by using index columns in your where clauses. As you can see in example, this query tries to match employees in the sales department, but it uses the upper function to convert the department value to uppercase. This is inefficient because when you use a function like upper on an index column, MySQL can't use the index, so it will have to scan every row to check if the department value matches. By querying directly against the column without a function, MySQL can use the index created on the department column, if present, resulting in faster performance. Joins are common in SQL, but they can significantly slow down queries if not optimized. The key to optimizing joins is ensuring that the columns used in the join condition are indexed. Inner joins tend to be faster than outer joins, so choose the appropriate join type. This query retrieves the employee_ID from the employees table and the department_name from the departments table by joining the two tables on their common column department_ID. Join combines data from two tables, employees and departments, based on a related column, department ID. E and D. These are table aliases or shortcuts to avoid writing full table names. Your where clause is one of the most important parts of your query for performance. SQL uses it to filter data, so ensuring that you're filtering on index columns and avoiding unnecessary conditions is key. Be mindful of using functions in your where clause, as this can prevent the use of indexes. This query retrieves all orders made after January 1st, 2024. Assuming the order date column is indexed, this is efficient because the database can quickly locate the rows where the order date is after the given date. Using a function like year order date forces MySQL to apply the function to every order date value, which prevents the use of an index on order date. This makes the query less efficient because MySQL has to evaluate every row instead of just looking up rows from an index. Aggregating data with functions like count, sum, and average can be expensive for large datasets, especially when using group by. Ensure that the columns used in the group by clause are indexed. Another strategy is to use temporary tables to pre-aggregate data. This query counts how many employees work in each department. It groups the employee records by department and then counts the number of employees in each group. Group by groups rows that have the same department value so that aggregate functions like count can be applied to each group. Subqueries and joins are often interchangeable, but they can have different performance impacts. As a general rule, joins are more efficient than subqueries because SQL executes joins more efficiently by leveraging indexes. However, subqueries are sometimes more readable for complex operations. This query retrieves the employee ID from the employees table and the corresponding department name by using a subquery. A subquery is a query within a query. Subquery is less efficient because it has to run the inner query separately for each row. Using a join to fetch the department name is more efficient. A join retrieves the related data from both tables in a single pass, instead of running a subquery multiple times. When querying large datasets, it's often useful to limit the number of rows returned, especially for pagination in web applications. Use the limit clause to control the number of rows retrieved, and make sure to use an indexed column for ordering the data. This query retrieves 10 employees starting from the 21st row because of offset 20. It orders the employees by employee ID and then uses the limit clause to get only 10 rows. This is often used for pagination to show limited results at a time. Example, for pages in a web app. Inserting or updating large volumes of data can also cause performance bottlenecks. Instead of inserting or updating rows one by one, use bulk operations whenever possible. Breaking large updates into smaller batches can prevent locking issues and improve performance. This query inserts 2 new employees into the employees table. The first employee, John Doe, works in HR with a salary of $50,000, and the second employee, Jane Smith, works in sales with a salary of $60,000. Insert into adds new rows to the table. Values specifies the data to insert. Identifying and resolving performance bottlenecks often requires a combination of techniques. Start by reviewing query execution plans, then consider indexing, query restructuring, and batch processing to resolve slowdowns. Database-specific optimization tools like MySQL's slow query log can also help identify problematic queries. Let's take a real-world example to see these techniques in action. Imagine we have a sales database with millions of rows, and we need to retrieve the top-selling products while keeping the query response time fast. We'll use indexes, pagination, and optimized joins to achieve this. This query retrieves the top 10 products based on their total sales. It groups the rows by product ID, sums up the sales amount for each product, and orders the results by total sales in descending order. The Limit 10 clause ensures that only the top 10 products are returned. In this video, we explored optimizing SQL queries for large datasets. In the next video, we will have a quick recap of what we have learned for using SQL for data analysis. Don't forget to like and share the video, and subscribe to the channel for more exciting tutorials.